Hi, this is Bob Kramer. I'm in the garage today working on an engine rebuild project, and the engine is for a 1980 Honda Goldwing. It's a four-cylinder horizontal motor. Anyway, what I'm doing today is I'm installing the pistons and piston rings. So I'm going to make a little video about how to install the rings and correctly, and of course measuring the end gaps on the rings. So stay tuned, and I hope you enjoy this. Okay, these are the new piston rings. I had trouble finding new rings for this motor. Of course, it's 40 some years old. But I found this company, IMD Pistons, in the UK. I was hoping that they were actually making the rings in the UK, but when I got the box, it says they're made in Taiwan. Uh, Quality does look good, though. The top ring is chromed, and the second ring down is all black, is black iron. So yeah, there's the chrome top ring. Let's see, wait a minute. Okay, chrome top ring, black iron second ring, and then just steel oil rings. Okay, so they're going to go into these bores, which I honed yesterday, and hopefully my honing is good. Let's light it up a little bit. So you can see the cross hatch in there. That's a 240 grit hone, okay? And we're going to do the rings. Okay, I'm going to start with the number 2. This is the number 2 piston. You can see I put a punch mark on each piston. 2 punches, of course, is the number 2 piston. The top of the piston is this mark here, so that indicates the top. And when I put the punch marks in, I also make them facing forward, so I know that that's the front of the piston as well, or it faces the front of the engine. That way I can assemble them the same way they came out. Now, here's the new ring. This is the top ring, all right? And you insert it into the cylinder like that, and then rotate it in. Like that. Then we use the piston itself to make sure that's straight in the bore, okay? It's important for that to be straight in the bore when you measure it. What we're doing right now is we're measuring the end gap on those rings to make sure they are the correct tolerance. And how do you know the correct tolerance, you might ask? You have to look in the engine specifications in your manual. Okay. Right here in engine specifications, you can see this is specifications in the Honda manual. Okay, so you look this up and it says ring end gap, top and second ring. Okay, I'm reading this for you. And here's the standard. This is the way it came from the factory, 0.1 to 0.3 millimeters. This is the service limit, so if it measures above 0.6, it's no good. Ideally, it's going to be within the factory standard. Okay, now these rings that I got from IMD are a little over factory standard. So, which is a little disappointing. Okay, so here's the feeler gauges. So I don't know if you can see the numbers on them, but anyway, I'm using this a 0.3 millimeter, and then so we're going to start with that one. This is a 0.1 down here. Okay, so I'm going to start with a 0.3. Let's see, which one is it again? I got a 0.3 is here. Okay, so we slip that into the end gap. All right, 0.3 does not go. That's good. That's a good thing. Here's a 0.15. 0.15 goes. Remember, the tolerance is 0.1 to 0.3. So 0.15 goes in and 0.3 does not. So that one is within factory spec. If it's too tight, if a 0.1 will not go in, it's too tight, it's going to have problems. And we're going to measure all the rings the same way in both cylinders. Keep in mind that when you do the oil rings, they have a different tolerance. The tolerance for the oil ring, it's also in the book right here. Oil ring, okay, side rail. That's 0.2 to 0.9 millimeters. 1.1 millimeter is the service limit. All right, the 0.3 on this one does fit. So now I'm going to go to the 0.6. Remember, our service limit was 0.6. And that should be a no-go. Actually, I'm going to go to 0.38 first. Hopefully that's a no-go. Yeah, okay. 0.38 is a no-go. So we're slightly out of original factory spec, but we're well within the service limit. So we're going to call that acceptable. Now also, I'm keeping the rings marked for which cylinder I'm testing them in. If I test it in the number 2 cylinder, when I assemble it, I'm going to assemble it in the number 2 cylinder. There could be slight variances between the cylinders, and I don't want to have a problem. All right, remember this one was 0.6 to 0.9. My gauges don't go to, let's see, I think my thickest gauge is, I think that 0.6 is my thickest gauge. 0.3, where is the 0.6? There's the 0.6. Yes, okay, so this 0.6 is my thickest gauge. It looks like 0.6 doesn't go. Okay, good, we found one that's too tight. So, if the ring is too tight, you need to file it. So we take a small file and we go like so. Okay. Now, these are steel. These are pretty much like mild steel. So they'll file easily. Let's recheck it. Point 6. My 0.6 almost goes. I'll file it a little more. Almost doesn't count here, I guess. It does not. Almost does not count. It needs to go. If these are too tight, obviously, when the engine gets hot, they're going to expand and could cause problems. That one's very close. That's 0.584 is sliding in there. And I bet they're in a little bit crooked. No, 0.6 is going in too. The oil rings are not nearly as snug in there, and they're much more flexible than the compression rings. Okay, done. We're going to do all 4 cylinders the same way, and then we'll be assembling the motor. Okay, I've measured all the rings and verified that they are within tolerance. Okay, and you have to do that even with brand new rings. You need to check. Now, when you look on the box here, you'll see, hopefully you'll see, that they actually tell you which ring is the top, second ring, oil rings, and so on. Okay, and they tell you how to install it. So the ring is marked with an R. Get a ring. This is the compression ring. Hopefully my lighting's good enough that you can see it. Let me turn on some additional lighting. There. Okay, now. Can you see the R on there? So that faces up. This is chromed on the edge, so that's the top ring. The second compression ring is all black. Okay. Now, when I assemble this, I put the rings in the same piston that they were tested in, the same bore they were tested in. So this is number 2, and let's mark this for clocking the rings. So remember, this is a horizontal motor, and this is the top of the piston, this is the bottom. Okay, so I want to put one gap at 10 o'clock, one gap at 2 o'clock on the oil ring. Those are the compression rings. And on the oil ring, there's going to be one gap at 4 o'clock and one at 8 o'clock. So that's how I'm going to clock my rings. I don't put anything down here between 4 o'clock and 8 o'clock. I don't put any gaps, because in a horizontal motor, oil sometimes collects behind the piston on the cylinder wall back here, and it can seep through and into the combustion chamber, and then when you start the motor, it'll blow out a cloud of blue smoke. So in my attempt to avoid that, I don't put any gaps in the bottom part of the piston. Now we start with the oil ring at the bottom. Let's get my rings sorted out here. Now the oil rings aren't marked top and bottom. They can go either way. It doesn't matter. So, okay, when you put in the oil ring, put in the separator first. Put the separator in. I'm putting the gap near the top of the piston on that. Then we're going to put in the bottom side rail. They call that the side rail. And that one is going to be here. And these are quite flexible, these side rails. Try to keep that in front of the camera. I hope I am. The compression rings are not nearly so flexible. So I'm going to get that one over here at 8 o'clock. And then this one's going to be over here at 4 o'clock. Okay, gap there on the bottom one. Okay, now my second ring, this is the black iron ring. Okay, so I'm going to put this one up here at the 10 o'clock position. I'm going to put the gap. All right, this one's a little bit tricky to put in. These are quite a bit stiffer than the oil rings, and it's also, being cast iron, it's a little bit brittle, so you have to be quite careful with this ring. And it's going to want to fall into the top groove too, so you have to prevent that as well. So when I get around to here, I'll insert a flat tool. This is actually an electrical tool for separating connectors, but it's very thin and flat, and I can use it to work that ring down without it getting caught in the other groove. Without that, that second ring will try to get caught in the top groove, and it can be difficult to get out. Okay, and you notice the R is facing up, as it should be. And now this is my last one. The R is going to face up, and this one's going to go over here at 10 o'clock. This one's easier to put in because it doesn't have an extra groove to fall into. Okay. There we are. All right, now I'm going to show you one more thing here. This is these pistons are going to be installed on the crankshaft, and then the block is going to be lowered down over them. So I have to have a small compression ring in there that can easily be removed later after the piston is in the block. So what I do is I take a 3-inch hose clamp, I brush some oil in it, put it on this piston. Now, this has to be facing a certain way. It has to be facing, let's see, it's got to be facing the top, like that. Okay, I'm talking about the screw, because when the engine is assembled, these are very difficult to remove, and it's much easier if the screw is facing the top of the motor. All right, now I got to be careful not to disturb the clocking of the rings, and I did. Okay, that one's over here at 10 o'clock. This next one is, okay, that's good, that's good, okay. Another thing, I should mention that you have to make sure that the rings move freely in their grooves, okay? And there is actually a side tolerance for those. Let's see, top. This has to face that way. There is a tolerance for those. You could go one step further and stick a feeler gauge in there. I've never had a problem with the side tolerance on the rings, so, and I did clean the ring grooves very well, so that's important that the ring grooves are very clean. Make sure we've captured all the rings in there. If you've never assembled a horizontal motor, you might not be aware that you have to put a ring compressor on like that, and then the block is going to get lowered down over that, and the ring compressor will get pushed off, and it'll be down here around the connecting rod, and then you have to reach inside the motor to remove that. and I'll show you that in the next part of this video. All right, so let me finish that up. All right, I'm assembling the pistons onto the crankshaft now. I just put the number 2 piston in, and I'm now doing the number 4 piston. Now, as you can see, I can turn this engine over by hand. Back that up a little bit. Set that piston up on here. You have to be careful handling these pistons after they're assembled on there. So you can see when the engine's running, when the piston's at the bottom dead center, it's right down there, almost touching the bearing caps and the rod of the other piston, the opposing piston. All right, this is number 4, and this is the last piston to go on the crankshaft. The rods and caps are marked. It's very difficult to see it, but there's a scratched mark in there. It's a number 2 in this case, and those marks have to stay lined up. Now, it's really hard to see when you're assembling the motor, so I'll take a magic marker and do that. All right, so now I have an ink mark there that'll give me a quick reference to make sure I don't get that cap on backwards. And incidentally, when you take this apart and put it back together, you have to make sure that you don't get any of the caps and rods mixed up. They have to go back together the same way they came apart. Now, this is only a 40,000 mile engine, so the bearings and everything are still good in it. Now, this has an oil hole to get oil into the bearing, so we want to make sure that oil hole is clear, like that. All right, and I'm smearing oil. This is just motor oil, 2050 motor oil. Now, the piston is marked. The 4 punch marks for indicating number 4 have to face the front of the engine. The front of the engine is the side toward me, so that's going to drop on there like so. I'm going to lay it over. Notice I put a rag over the transmission gears. Just to double check, yeah. So my ink mark is up. Ink mark on here is going to be up. I'm going to put oil on the bearing. The bearing's oiled. Slide it in straight. It won't go if it's not straight. Okay, then we put a little oil on the nut and the thread. Screw that on. Just draw it down until it touches, and then rotate it over the other way, and we can put the other nut on. And then these need to be torqued to about 23 foot-pounds. I'm going to do that in 2 stages. So the first stage is going to be 15. 15, flip it over, get the other side. There we go. 23, or slightly over. Got it. I'm going to double check the other side. Yep. Okay. All right, now the next step is I need to turn this. If I turn that, my rings are going to move. I can leave it like that. All right, the next step is we need to get both pistons even. Now, as you can see, the engine will roll over by hand. If you can't turn the engine by hand, something is not right. All right, now I need to get some blocks of wood that are going to fit in here to hold the pistons upright, and then I'll prepare this for assembly. I have to put some O-rings in.